In the last video we talked about arrays such as vectors, matrices or tensors. And in this video I want to talk about another data structure called tuple. And as always, the notebook is available from the Julia course repository. It's called 3-tuples.jl and it's also available as a direct link here. So a tuple is a little bit like an array. It's an ordered set of elements. But the key differences between them is that first, a tuple is immutable, meaning that once declared, we cannot change any value inside the tuple. And the second key difference is that we track the type of each element inside a tuple, which is not the case in an array. And this is exactly those two reasons why tuples are better for performance. Well, at least it's the case for short collections of elements. So how do we declare tuples? Well, it's rather simple. You list all your elements separated by commas and you put them inside parentheses. And as I said before, a tuple tracks the type of all its elements. So if we use type of on T, which is the tuple I just declared, well, we get tuple and then we get the type of each element. So the first element is an integer. Here it's 1. The second one is a float. The third one is a string. And the fourth one is a character. So how do we index inside the tuple? Well, it's simple. It's like for arrays. So if you want the first element of your tuple T, you use brackets and the index of your element. And again, like for arrays, you can use ranges. So if you want the second to the last element, you will use to, column, and the end keyword. And because tuples are immutable, if we try to assign a new value to an element of a tuple, Julia would return an error. If you're coming from R or MATLAB, I know that immutability seems very inconvenient for users, but it allows much faster computations. So if you're developing a package, for example, you would want to consider tuples for some data structures, at least for collections with few number of elements. If you have more than 32 elements inside your collection, consider using static arrays. I put a link just here. And I also put the video from Christopher Rakwas on YouTube because he explains very well why structures like tuples are very fast. And now let's talk about a very nice addition to the tuple family, naming the named tuples. So named tuples add the very nice feature to associate a name to each value inside the tuple. So how do they work? Well, we associate a key to each value inside the tuple. For example, if we have 2 apples, 10 bananas, and 3 mangoes, we can name those values with the name of the fruit: apples, bananas, and mangoes. And like for tuples, if we want to declare a named tuple with a single value, we just have to put the single value with this key and then use a comma with nothing behind it. And it's different than just putting this like this, because this is not a tuple, it's just a value. We can also use functions inside named tuples or tuples declarations. For example, if we want to declare a new named tuple which summarizes our fruits value, we will declare a new tuple with the key being fruits and the value being the sum of all fruits and the comma, of course, and we will get a new tuple with key fruits and value 15, because 15 is the sum of 2, 10, and 3. Another benefit of using named tuples is that we can index them using the dot syntax. So for example, if we want to retrieve the number of bananas inside fruits, what we will use is just fruits.bananas, and it will return the value inside bananas, which is 10. And if you don't remember what are the keys inside your named tuples, you can use the keys function to retrieve all the keys. So for example, if we use keys on fruits, we get apples, bananas, and mangoes. And same goes for the values. If you use the values function on fruits, you get just the values 2, 10, and 3. And we can even complexify the structure of our tuples or named tuples by using recursivity, some kind of recursivity. So for example, we can declare a new tuple called rectuple with a first element being fruits, the key is fruits, and the value is this named tuple. And the second is vegetables with again a second tuple. The first tuple is also a named tuple with banana equal 2 and peach equal 5, and for vegetables we have zucchini equals 2 and pumpkin equals 2. And we can still index, for example, peach or zucchini or pumpkin using the dot syntax. So for example, to get zucchini, we will do rectuple dot vegetables, which is here, dot zucchini, which is here, and it will return the value 2. And we can still use the regular way of indexing using integers. So for example, if we want to get the value of peach here, which is 5, we would index the first element of rectuple, which is fruits, and then the second element of fruits, which is peach, and we will get 5 because it's the value of the element peach. And finally, there are some useful functions that I use regularly when working with tuples. So for example, the most simple one is the length function to obviously get the length of your tuple. And the second one is not a function per se, but more a technique, and it's called splatting. And splatting means providing values as if they were single arguments to a function. For example, if we want to create a new tuple with the values of fruits, but adding a fourth value, for example 5, well, we can do this manually like this, but we can directly use the values stored inside our fruits tuple instead. And to do so, we splat the values of fruits inside a new tuple with a fourth value. And splatting is done using 3 dots after our tuple. And the 3 dots here are just used to take the values from fruits and use them as arguments of the tuple function, which is exactly the same as providing the values as arguments as we did before, 2, 10, 3, and 5. But very different than using fruits like this. If we don't use, for example, the 3 dots, what we would get is this, which is a new tuple with the first element being a named tuple with the values of fruits and the second element being just 5. And of course, if we add again the 3 dots, we get what we want. And the last function I use regularly with tuples is isEmpty. Well, here it returns false because A is not empty, but if we create an empty tuple B and we use isEmpty on B, it will return true. And well, that's it for the video on tuples. Thank you for watching, and if you have any questions, feel free to ask them in the comments. See you next time.